Okay, hopefully you can see a large purple slide, shifting Terraform security left. So as Nick mentioned, I'm Gareth Rushgrove. So I'm Director of Product at a security company called Sneak. I'm based in Cambridge in the UK, though we're all over the place. I'm also the curator of the DevOps Weekly newsletter, and I contribute to a bunch of open source projects in what's vanishingly small spare time I appear to have. One of which I'll talk about a little bit later on. So in this talk, I'm going to talk about, and I guess like cloud security in general, because ultimately Terraform is all about provisioning things on the other side of APIs, and it's often those things that result in like sort of being exploited or are insecure. I'll talk about a little bit of a sort of introduction very briefly on static analysis. Like, what is it? Why is it useful? What are some of the pros and cons of static analysis? And really just dive into a load of different example Terraform specific tools in this space. I guess the idea has been around for a little while, and the idea certainly predates Terraform from a static analysis point of view. But seems to be an explosion of recent open source tools in this space, and I think it's interesting just to have a look at some of them. I'll jump into demos, not of all of those, but a couple of them sort of highlighting, I guess, different approaches. And then just like wrap up with a few sort of hopefully high-level points to take you on your way. Okay, so hopefully folks are still with us and like the sound of that. So cloud security. Ultimately, that's a really broad topic. There's all sorts of different aspects to it. What I'm mainly going to sort of narrowly look at is how well configured is your cloud environment? Mainly because that's obviously very relevant to the work you would do with Terraform. It also happens to be a big problem when it comes to how secure is your environment overall. So the Capital One incident not too long ago, the sort of like quite high profile public breach, and they pointed at that, well, this was a configuration issue. This was a misconfiguration in this case of a sort of firewall or proxy that led to the intruder being able to get access to systems that they definitely were not allowed to do so. But it's not just high profile exploits. And Rapid7, actually from their penetration testing work, and some kind of misconfiguration is encountered on the penetration test over 96% of the time. So basically, it's nearly never the case that people haven't made configurations. And remember that this is a penetration testing company looking at infrastructure configured by people who have paid a penetration testing company to do so. There's a reasonable bet there that they're like both interested in the results and paying some infrastructure people to build their infrastructure. And it's still 96% of the time, there's some edge misconfiguration. Doesn't mean that that leads to an exploit, but you don't want to leave all your doors open if you can avoid it. Even the US government, from a recent report, was saying sort of, again, like while cloud service providers often provide tools to help manage some of these risks, like misconfiguration of cloud resources remains the most prevalent cloud vulnerability. It's a problem, and it's leading to exploits, and it's leading to high profile exploits. So hopefully you buy the problem side of it, which will shift more onto, okay, so what can we do about this? Some people might have come across the Center for Internet Security. So it's a body that produces, and often what are called this sort of CIS benchmarks. They cover a wide range of different software, and you can download these often for free from the website. And there is actually a benchmark. There's actually one for Kubernetes. There's one for the Docker runtime as well, which you might have seen. There's also ones for Azure and AWS in particular, which are obviously very relevant to lots of the use cases Terraform is put to. And these are a really good source of data because they cover roughly sort of 50 different misconfiguration problems, or mainly configuration problems, across a set of the AWS and Azure services. And they're very detailed. Like for each of those sort of 50 rules, it's not just the text you'll see here. It goes into detail about, well, why is that a problem? How to resolve that problem, including configuration snippets or screenshots where relevant. So they're definitely worthwhile, but you can either think of 50 rules as a lot, or you can think of it as a small number. They certainly don't cover the whole gamut of the cloud services that's on offer today, but they're definitely a good starting point. They represent, I guess, a lot of the low-hanging fruit, similar to the OWASP top 10. That's not all the things that could be vulnerable, but it's often the ones that are. So starting there is a good starting point. The downside of these is they are quite verbose text documents. So ultimately, you're going to have to go through and read them, interpret them, look at your actual configuration and reason about that, whether it's secure or not. So a good starting point, a lot of good data and research. But as a sort of software person, you'll probably look at them and go like, can I have this in a tool? How do I apply this automatically whenever I want to make a change? And that's really where the idea of static analysis comes in. As I mentioned, static analysis isn't something that's specific to Terraform or specific to any sort of programming language. It's not a new idea at all. It's just the idea of analyzing computer software that's done without actually executing that program. It's without necessarily building a binary or running the code. And that could be compiling Java code or executing a Ruby program or running Terraform to result in some infrastructure being spun up. Ultimately, static analysis is saying, well, you have some source code. Can I look at just that on its own and identify problems? And ultimately, it's often fitted into a sort of workflow at the start. So often that sort of testing progression, like you'll have your unit tests, you'll have integration tests and acceptance tests. And again, this is generic to software development. You can certainly apply this to Terraform, and people do, but for just generally, static analysis would come often at the start. The reason for that is it's often the same for everyone. And it's also often sort of, I guess, something that you can drop in without too much, hopefully, configuration versus something like unit testing, which ultimately is generated. You have to write your unit tests, acceptance tests and integration tests the same. So bang for buck, it can be something that's a great place to start, whatever programming environment you're using. You'll see lots of linters that are, broadly speaking, applying this sort of approach. The other advantage, really, and one of the reasons to start often with static analysis tools, is that they're fast. Providing fast feedback is critical to sort of like doing the right thing in a timely manner. And having something that can be used locally and in your CI pipelines that provides really fast feedback purely based on the code without having to run it, execute it, requiring other infrastructure to spin up in a sort of test environment, can provide a lot of value very quickly. Because then you start asking questions like, well, here's some Terraform code. Can you spot the issues? Now, there's sort of a few caveats here. Obviously, that's not a lot of Terraform code, is one of them. Your repositories are likely to contain lots of different files. You might have many repositories or a single sort of monorepo, but you're certainly going to have more Terraform code than this. It's likely to be more sort of structured and spread out and sort of factored in a way that makes sense for the organization, but maybe means you have to look at multiple places to really reason about it. Certainly from a low-level security point of view versus a higher-level abstraction. So with those caveats out of the way, well, yes, and I can spot a few security problems. I was probably not going to pick Terraform code that didn't have any, because that would make the slide less interesting. But we can see that we've got wide open ingress rules. Again, maybe there are contexts where that's fine. And that's one of the sort of nuances of static analysis. It's not magic. It's not able to discern anything other than what you provide as input. So maybe that's fine, maybe it isn't, but it's certainly a potential issue. Similarly, you might have a good reason for using HTTP, but most of the time, you probably should be using HTTPS. The use of an unencrypted transport protocol is not always a great idea. Again, there'll be exceptions, and that's one of the flaws with static analysis. You are going to get those sort of false positives. Unencrypted storage, again, here's another example on here. I think there's a couple of others, but I won't dig into them, see if anyone spots them afterwards. So if we've got ultimately misconfiguration being a sort of real security problem, but we do actually know some of the things that should be configured better. And we've got Terraform code that creates that infrastructure. Ultimately, it's easy to reason about static analysis tools for Terraform. And the nice thing about, I guess, relatively simple ideas of static analysis has been around a long time. We do have good documentation about what are good and bad configurations. This is not a novel or original thought. So people have been busy hacking. And there's quite a few tools in the Terraform ecosystem that have been looking at this sort of static analysis for Terraform code. So one of them is TerraScan. So I've not used this in Anchor at all, but this is ultimately based on the Terraform Validate library. That is actually a Python library you can build a whole bunch of different tools on top of. TerraScan takes that and ultimately writes a bunch of rules for you, specifically around security. So it currently has about 35 rules or so, mainly focused on AWS. But definitely an interesting tool to look at if you're, I guess, already using Python, if you're already looking at Terraform Validate, which is basically a tool for you to write your own unit tests for Terraform code. If you were using that, this can be really viewed as a bunch of pre-written tests that you can include in your test suite. So there's a lot of sort of utility there if you're already combining static analysis with unit testing. We'll come on to some of the crossover there as well. For example, is it unit testing if someone else wrote the tests for you? Because that has all the properties really of static analysis. Another tool, and actually pointing to this not being a novel idea, is Terraform from Wayfair. And so this is actually came about more than 2 years ago. It's actually not very actively developed at the moment, so it's maybe not the best place to start. I wanted to include it here really as a good historical note. Also, it does have a number of rules in there, and they apply to Google Cloud Platform. So there's a bunch of prior art around the types of things, if you're a Google Cloud user, you might be interested in testing for. So maybe not the tool you'll use. It doesn't appear to be maintained anymore, at least publicly. But certainly, I think it's important to include in the record. More recently, and actually not also written in Python, is Chekhov. So Chekhov, again, actually very recent. There's been lots of activity recently in this sort of space. So 3 months or so ago, it was published publicly. There are a number of active maintainers on the project. Again, written in Python, a growing set of rules. And in this time covering a number of different cloud providers. So I think if memory serves, there are a few more AWS ones, but certainly a set of Azure and GCP rules, as well as some generic sort of Terraform security practice in there as well. And Chekhov, similarly to a bunch of the other tools, provides a command line tool that you simply point at your Terraform code and it will check a number of these rules and give you feedback about what's good, what's not good. TFSec, very similarly, in fact, again, started at roughly the same time. Really, that sort of lots of parallel evolution going on here. TFSec has a sort of similar size rule set as Chekhov, maybe a little bit less, but more focused on AWS rules here as well. In this case, it's actually written in Go. And more the product of basically a single active contributor more than a group of people. But yeah, this has definitely been one of the sort of more recent and popular static analysis tools. I'll show a bit of a demo of this in a second as well with some code. But TFSec basically outputs quite detailed reports about the errors it finds. So not just that you have a problem, but it really helps you put that error in context. So which lines of your code are a problem, how severe is that problem, and commonly sort of assigning those things unique identifiers so it's easy to follow up in the documentation about why that's a problem afterwards. And last of the tools I wanted to talk about here, and I'll do a demo of Conftest, is the tool that I'm working on. Slightly different to the others. Again, you can think about it maybe falling into some of that unit testing areas, or if someone's written the rules, more of a static analysis tool. But Conftest is a tool for writing basically tests against any structured data. It's mainly built for testing configuration. So actually, it's not specific to HCL with Terraform. You can write tests against your YAML files or your JSON files, your INI files, TOML files, HOCON files, Q, Docker file, EDN, VCL for varnish configs, and XML if you're a sadist. So really about any form of structured data, feed it into Conftest, and you can write tests against it. It has some built-in tools for sharing using like container registries or Git or S3 as well. It has a plugin model as of yesterday as well. So there's a growing sort of tool set around it. Tests are written in Open Policy Agent, which is another open source project that I'll talk about in a second. And this is, I was the original creator of this, but there's now an active bunch of other folks maintaining it. We launched about 10 months ago. And yeah, that's written in Go as well. So out of the box at the moment, there aren't any security rules, but I'll show you how you can write them fairly simply. And we're already talking about a sort of sharing ecosystem around here. So I think we'll probably see some movement in the next few months on this as well. So Conftest itself, again, provides a command line tool that you can run against your Terraform files. With, I say here, at the moment, Conftest basically assumes Terraform files are using HCL, so they're prior to 0.12 sort of variant of the language. So you can write tests against both. There are slightly different parsing rules for both, however, as people have mainly discovered. So you have to explicitly opt in to HCL2. At some point, I think we'll flip the default there, probably before Conftest hits a 1.0 release. But here we'll output basically the failures that we detected. I'll show you what that looks like in a second as well. I mentioned Open Policy Agent there as an underlying library used by Conftest. And this is one of the other, I guess, advantages here. Open Policy Agent is a growingly popular open source project. It's one of the CNCF Cloud Native Foundation projects. It's usable as a library. If you've been around the sort of Kubernetes community, you might have come across it quite a bit. It's growingly popular outside that as well. Ultimately, it's a open source policy engine. If you've ever written something which basically it really sort of separates out some rules and their application, you've built a basic policy engine. Open Policy Agent basically takes that, keeps going with it, and then says you can use this as a library rather than writing a simple version of it every time you want to solve that sort of domain problem. There's a vibrant open source community. There's all sorts of work going on around it. And it basically allows you to write policy in its own DSL called Rego. It's actually a sort of data log variant for those that are familiar, and looks a bit like this. So, well, it looks exactly like this. These are some assertions actually for Terraform code. So here are actually, the first example is simply extracting out the protocol from any AWS ALB listeners. So, and wherever it finds those, it basically throws up one of those failure messages. It denies the request in the sort of power. One interesting thing about Rego, and bearing in mind this gets a little bit meta because we're talking about using Conftest in this context of testing our Terraform code is that Rego has a built-in testing framework as well. So one of the things that you discover with either writing unit tests or for structured data or for static analysis in general is, how do you know it's doing what you think it was doing? At the end of the day, it's still code. So Rego has a built-in testing framework, so you can actually write unit tests for your tests. That in particular is a really good property from the point of view of if I'm writing those policies, maybe a generic set of Terraform security policies based on the SIS benchmark, I can include a test suite with that. And you as a user can use that with some assurance that there's actually, it's well-tested code, not just it's a bunch of rules. Confidence has a number of built-in integrations to make it easy to apply. So it's not just the local CLI tool that you can grab from GitHub, but also from Scoop or Homebrew. We have a GitHub action that you can use, Tecton pipeline integration, Circle CI. Other people have been building some other integrations as well, I think with GitLab and the like. So with that, I will jump into a few demos and then close out. So if I, hopefully I've switched over to my terminal. Here I've got a very simple Terraform code, basically the file we saw earlier. I mentioned tfsec as one of the tools. Again, tfsec you run in a directory, and just like that, you'll get basically information back. I mentioned one of the advantages of static analysis is that it should be fast. Again, in this case, we're analyzing a really small file. In fact, the output was longer than the file in question, mainly because I'd filled it with likely issues. Confidence, as I mentioned, works slightly differently. Here, I've actually just got the policy locally, but this could be from elsewhere. I have both the set of tests and the policies themselves. And I can run Confidence verify to basically run those tests. Like, are my unit tests of that policy doing what I think it's going to be doing? And that's more for like developers of policy. Most people would just simply download those policies or download them from some sharing mechanism that we've got built in and run Confidence test. Again, I'm specifying that I want to use the HCL2 parser, and we can see we've got failures. So this is the policy code that I mentioned. You can see there are simply declarations for the different tests that we failed. And if I were to go in and start fixing some of the problems, obviously let's switch that over to HTTPS. Hopefully we'll see something less failures. Again, very simple, but that's partly the power of having tools that are fast and early in the pipeline. They should be simple to integrate with. There's loads of other features in Confidence that I think digging into now would be I would run out of time. But please do check it out and some of the other tools I mentioned. So wrapping up, like on time, I think as well. So one area, I know, as I've stressed a number of times, really is the advantage of static analysis is that it should be cheap to integrate and really have that sort of a good cost-benefit trade-off. There are issues around potentially false positives and false negatives. So static analysis can get a bad name where it's too noisy. So don't rely on it to tell you you're secure. Rely on it to identify problems that you can fix and that you should fix earlier in your pipeline. I think tools that provide like feedback when you're writing are really important. Like basically moving a bunch of these problems to like the author means that you will have less problems in production. A lot of sort of cloud security conversations become quickly compliance questions. They become about the thing you're running, and they become a compliance thing, and they can become after the fact. I think with Terraform and infrastructure as code, ultimately we can shift that into being something that we can address a lot of the problems a lot earlier. That doesn't make them all go away, and it doesn't solve compliance in general. What it does do is make that have a lot less noise involved, which I think can only be a good thing. It's interesting to note, I think, in the last few months, there's just been this explosion of tooling around Terraform and in this domain and others, I think. And a lot of the tools I shared there were new in the last year. Several of them were new in the last 3 or 4 months. So I think it's like that's a good sign for Terraform in general, in that people are starting to consider it a programming environment and invest in building tools. I think, again, some of them will succeed and build a successful open source project. Others will be useful footnotes. But both is useful in the sort of evolution of the stack, I guess. And last but definitely not least, I think Terraform allows you to start thinking about shifting security to earlier in the pipeline. Really catching those issues where you're developing your infrastructure, where you're writing your code, can mean you can have a tighter feedback loop on fixing a whole swathe of different issues. And hopefully then you don't end up as one of the people with one of those mea culpas of like, yeah, we were exploited because we had misconfigured infrastructure and we could have caught it earlier. With that, thank you for listening. And yeah, if you're interested in a bunch of sort of developer-facing security tools, do come and check out Sneak.
I thoroughly recommend everybody does that as well, because I'm a fan and a user. And wonderful presentation, Gareth. I really appreciate your time today. Contest looks crazy good.
It's great. And so I built it when I had a bunch of time on my hands between jobs. Released it at KubeCon last year, so nearly a year ago now. And it's just picked up a lot of, and then it was really narrow. Now it's picking up users from all over the place. People, because you can apply it to, and again, you can write unit tests for your Terraform code. At the same time, in the same dialect with the same toolset, you can write tests for your Kubernetes configs or Docker files or VCL things. Often we've had that sort of, you had to change tools. I worked on a lot of the Puppet testing tools and knew the people working on the Chef testing tools. And I think that's where a lot of that infrastructure testing ideas came from. But there was a lot of repetition of like recreating the wheel. With Contest, what we were trying to do was basically build something you can use to test any structured data.
Right. I mean, I dig that a bunch. It makes absolute sense to me. And I'm kind of like, I was watching you talk there and I'm thinking about like 1,000,000,001 possibilities that, hey, you know, there's another area of things that I need to test from a security perspective. What about my routing policies and my layer 7 configuration for my service mesh? I can test all of that. My Nomad job files. I love the fact that it just kind of allows you to structure, to test any form of structured configuration. I'm definitely going to be giving this a go.
No, please do. And yeah, and we've got a Slack on the Open Policy Agent Slack as a Slack channel on there for called Contest. Check out the repository. It's got all the README. It's got loads of examples, including the Terraform examples I showed here. And yeah, I think the next stage of that is really going to be about building that sort of sharing ecosystem into around open source, Open Policy Agent.
I love it. I'm a genuine fan. So I will definitely be bugging you on Twitter. You can
please do.
You might want to block me now.
No,
I can be stalky.
Gareth R on Twitter for anyone else who wants to bug me and not block Nick.
Thank you so much, Gareth. And I'm going to look forward to seeing you again soon.
Yep. Good. Thanks for having us.
A pleasure. Now,